Hello, and thank you for joining me today. My name is Mittal. Today we'll go beyond SLOs and see how AI is revolutionizing site reliability and sharing. So before we dive into specifics, let's take a moment to look at the roadmap for our discussion today. We're going to cover another important job related to SRE and how AI is transforming it. We'll start by talking about the core challenges that SRE faces today. That is set the stage for talking about why we need some of these advanced solutions for that. We'll talk about the what and the how. What are the different solutions and how they are applied and how they're articulated. We'll look at anomaly detection in a little bit of detail. We'll break down what anomalies are, the different types, how we detect them. But this is crucial for understanding how we can start to predict them. And then we'll look at some of the case studies for big companies out there will use some of these techniques successfully. We'll look at tools and technologies. We'll discuss the major open source and commercial options available for applying some of these solutions. We'll look at the future of AI and SRE, what the trends in this field are. And finally, we'll wrap up with some practical recommendations for getting started and applying these practices. All right. So what are the key metrics that we are going to rely upon as we start building these systems? In the world of SRE, metrics like availability, latency, throughput, and error rates form the foundation for doing an the analysis that we do. These metrics are the North Star, and they help us build reliable user experiences. We'll also talk about the monitoring explosion that is happening. So it's almost as if we've become too good at collecting data. And now there's an explosion of it. There's too many signals and too much noise. So that makes it difficult for us to pinpoint problems and understand what's really going on. It also causes alert fatigue, right? If there are just too many signals and noise coming in, we don't know what the false positives are, what the significant or insignificant pieces of data are. And this can be problematic because it can cause us to have a delay in how quickly we can implement solutions to these problems. Then we'll talk about the shift in predictive reliability. So traditionally, SRE has been reactive. We wait for things to break and then fix them. But today we're moving more towards being able to predict and be ready for problems to happen before they actually happen. And this is where AI and ML also come in. And we'll dive into these in the next section. Firstly, let's talk about the what. What can AI do for us? So one of the things it can do is intelligent alerting. What that means is AI can be used to rein in the flood of alerts that we can get if we are gathering too many metrics. Because AI can filter out the noise and identify the really crucial bits of data that we should be focusing on. This reduces alert fatigue and helps us focus on what is important. So the next what we should look at is predictive maintenance. So this is one of the major benefits of AI is its ability to look at past data and help us identify patterns that we can use to forecast our problems before they happen. So this proactive approach helps us avoid outages altogether. The next thing we should look at is automated remediation. So this is an exciting topic. So it can also remediate many of the problems that we face in an automated way. So when an issue is detected, AI can trigger corrective actions automatically. This significantly reduces the time it takes to solve problems and it minimizes downtime. And systems can become self-healing. AI also helps us in capacity planning. So this is another crucial area. AI can predict future demand and help us optimize resource allocation accordingly. This ensures that we have enough resources to handle peak loads without over-provisioning. and without wasting time. It also helps us be efficient and cost effective. We can use AI to do root cause analysis. So AI can assist us in quickly identify the root cause of problems. So to do this by analyzing various data points and correlations from the past, and it can identify and point to source of issues, saving us of time and effort that you would have had to otherwise spend to do this using traditional approaches. We can also use AI for incident management. So AI can automate various incident management tasks, such as ticket creation and prioritization. This streamlines the incident response process, and it ensures that critical issues are addressed promptly. And let's talk about chat-ops enhancement. Finally, AI can enhance chat-ops by using natural language processing to interact with systems and run diagnostics via chat. This makes it easier for teams to troubleshoot and manage systems in real time. Now let's talk about the how. We've seen what AI can do in the field of SI. Now let's talk a little bit about the how. Let's look at the different machine learning algorithms and how they're applicable here. So there's of course supervised learning. So think of this as AI learning by looking at past examples. So we provide labeled data where we've had the correct outcome or data about incidents from the past. And AI can use that to identify what issues look like and what resolutions have been in the past. There's also unsupervised learning. So this is where AI can find patterns on its own without labeled data. So this is incredibly useful for anomaly detection. AI can look for unusual behavior and deviations from the norm. Like saying, hey, does something look off here? Let me know if something looks off so I can investigate. For example, if there is a sudden spike in traffic, then, anomaly detection algorithms can identify it because it looks different from what the non-spike behavior is. There's also reinforcement learning. This is where we're training our AI through trial and error. AI takes an action and it receives feedback from us, and it uses that to improve how it does remediation the next time around. For example, using this, it can find optimal ways to respond to critical situations. For example, AI can try different ways to restart a service. One method fails, it can realize that and look for a different approach. Let's talk about the different anomaly detection techniques. So there can be statistical methods. These are based on statistical techniques where we are looking at our data and calculating various scores and using that to identify anomalies. So for example, with a Z-score, we're measuring how a specific data point deviates from the average. With the MAD, we are measuring how it deviates from the median. And this can help us identify outliers, like individual data points that significantly differ from the rest. For example, if the average response time is 100 milliseconds and we see a sudden spike of 500, we know this is an outlier because this will significantly deviate from the average or the median. We can also use clustering techniques. So we can look at groups of data points and we can cluster them together and see what doesn't fit in the cluster, and that becomes the outlier. So it's like finding an odd one out. So an example would be if GPU utilization falls outside of range. We are seeing consecutively some utilization and then suddenly there's a different utilization number. Then it falls out for the cluster and we know we should focus on that. We also have different AI ops approaches that we can use. So these are different ways in which AI can be incorporated in our SRE practices. For example, we can have the overlay model, which is pretty much about taking our AI capabilities and running them alongside our existing tools. So our current monitoring systems and alerting systems stay in place, but we add an AI layer that gives us additional sort of signals or additional insights that we can use to make decisions. This is a good on-ramp to AI and SRE because it doesn't require replacing a lot of existing infrastructure, and we can go step by step. The other approach is with embedded models. So think of this as a set of monitoring platforms that can have AI capabilities already built into them. So many modern platforms now offer AI-driven anomaly detection or predictive analytics or automated learning. So these help us create streamlined workflows and give some more integrated experience. And then one very crucial aspect of how AI works in SRE is with automated remediation. So AI can go beyond just detecting problems. It can also take corrective action. Right? So this could involve things like restarting services, scaling resources, triggering other automated workflows. All right. Now, what are some of the challenges that we face implementing this? One is, of course, with data quality and data requirements. For implementing any of these approaches, we need access to a lot of high quality data, which may or may not be available. AI is very data intensive set of approaches. If data is incomplete, inaccurate, or noisy, AI performance suffers. So we need to invest in robust data collection and cleaning and management practices. Another challenge we run into implementing this is with just the training and tuning of AI models. So this is an ongoing thing. We can put systems in place, but we also need to invest in making sure that these systems are continuously trained with data as it evolves. The data that our system sees evolves over time, and so our systems also need to be aware of the new normal. All right, let's look at anomaly detection in a bit more detail. So anomaly detection at its core is just identifying deviation from the expected. So we first need to identify what the behavior is. And we can do that by learning from historical data. So we understand what normal looks like, so we can spot what is not wrong. Here are some types of anomalies. For example, a point anomaly is a single data point that is an outlier. It stands on its own. So for example, a sudden spike in CPU utilization on one server, the example of a point anomaly. Could also have the contextual anomalies that are unusual in a given context. So some system behavior might be normal in one situation and become anomalous in a different situation, right? So for example, if we see various spikes in our system utilization during a normal workday, that might not be unusual, but if there is a spike in CPU activity, for example, at 3 a.m., then that might be abnormal. That's an example of a contextual anomaly. Another sort of set of anomalies are just behaviors that we see only when we collectively look at various data points. So for example, a gradual increase in latency across multiple services over time, right? So any one of those points by themselves may not be an example of anomaly, but taken together, they give us a signal that something is wrong. Okay, what are some of the ways in which we can detect them? There are statistical methods. So these involve just analyzing data distributions and identifying outliers. And as the name suggests, we applied this by using various statistical techniques, the moving averages, exponential smoothing, to identify what an outlier is in a given set of data. We can also use machine learning methods. So we talked about clustering just now. So clustering, fancy forecasting, or other ways in which we use machine learning methodologies to cluster information or to create a sense of what normal is, so that we can identify when something is outside that normal. So what are the challenges we run into with anomaly detection? So one is, of course, seasonality. Many businesses have seasonality in their sort of system usage. So that needs to be factored in. what constitutes normal changes at different times of the year or different times of the day. Another problem is with data that might be noisy. So we might need some pre-processing to filter out the noise so we can accurately identify what a true anomaly is. We can also have situations where what constitutes normal evolves over time. So as systems grow, as usage patterns change, what might be normal today might not be normal tomorrow. So we need to invest in ongoing sort of training and tuning of our algorithms to make sure that they are current in terms of what is normal. And there might be cost and effort involved in making sure that our data is labeled correctly so that AI systems will use them effectively. But despite all these challenges, anomaly detection is crucial and is a very important technique for catching issues early. All right. Let's talk about a few case studies. These are all publicly available and actually, if you're interested, so Netflix and how Netflix used anomaly detection to prevent streaming outages. So Netflix, as we know, is the massive streaming service. They have probably the largest streaming infrastructure, one of the largest in the world. And they rely heavily on anomaly detection to identify when something is going wrong with their system. So they continuously monitor their vast network. They look for anomalies or any unusual patterns. And by identifying these things early, they can take proactive steps and have been by and large good at preventing streaming outages and ensuring smooth viewing experience. So whenever they have a new launch of a blockbuster movie, they're able to predict ahead of time the kind of spikes that they might see and they plan for it. So the other system we should talk about is LinkedIn. So LinkedIn is, of course, the huge professional network that we perhaps all of us use. And they face the challenge of quickly resolving incidents. So they have an AI-powered correlation system that's able to analyze a lot of different data sources and identify relationships between these events. This helps them pinpoint root causes of problems much faster than manual investigation would have. So as a result, they significantly reduce their FTTR and minimize the impact of incidents on the user. So this is another showcase of how AI can streamline incident response and improve efficiency. Uber, the ride-sharing service many of us use, is another case study in how AI was used successfully in the realm of SRE. Uber faces a lot of fluctuating demand, and they use machine learning to predict future traffic patterns and rider demands. So with this, they're able to automatically scale their infrastructure up and down as needed. By predicting demand, they ensure they have enough resources to handle peak times, and they don't waste money over provisioning during off-peak times. This illustrates how AI can be used for proactive capacity planning, for resource optimization, and thereby saving cost and improve the performance. Okay, let's look at some of the most famous and popular tools in this space. Right? And we have open source as well as commercial tools and platforms that can be used depending upon our situation. So some of the really popular ones, Prometheus, it's a metric collection and storage system. It's a thing for gathering time series data, which is forced to fit for anomaly detection. Grafana is a visualization and dashboarding system. Using that, we can visualize some of the metrics that we're capturing and we can visualize anomalies. Yeah. There is the nth stack of tools, the Elasticsearch, Log/Grafana. So with this stack, we can do log management and analysis. We can collect and process and search our logs, and this is very useful for root cause analysis. There's Profit for Facebook. This is a useful tool for predicting future trends and patterns. So using this tool, we can do things like capacity planning and proactive monitoring. Then there are, of course, tools like Scikit TensorFlow, PyTorch. So these tools can be used if we want to build our AI ML systems from scratch and apply some of these algorithms ourselves. Then there are Trolley platforms like Datadog, from anomaly detection and forecasting, New Relic, which has automated incident intelligence built into it. There's Dynatrace for automated monitoring, and Splunk, which is log capturing system, which has very advanced log analysis and anomaly detection systems built into it. And depending upon whether we are on the Amazon ecosystem or the Google Cloud ecosystem, there are AI tools built into these providers that help us do anomaly detection, forecasting, log analysis, a variety of these practices. All right. So where are we headed? So we know that there is going to be increased automation, especially in the field of incident response and domain broken. AI will not just detect problems, but will also trigger and execute corrective actions, corrective workflows, and it can do a variety of things before human intervention is needed. Sometimes human intervention is not even needed, and it can speed up recovery. We know that there are going to be more and more self-healing systems that can detect, diagnose, and fix problems all on their own, so without or with minimal human intervention. Self-healing system is becoming more and more of a buzzword, and AI and ML are powering that. We're going to have gradually more and more sophisticated models that have the ability to detect more complex problems, and then using deep learning, they are able to analyze a vast variety of data sets, so vast varieties of data, and identify problems that otherwise may not have been caught. Another trend is the rise of explainable AI. We don't just want AI to make a decision or make a prediction. We also want to understand how it got to that point, why it made a certain decision. And explainable AI is the approach to look inside the black box to see how AI is working, so that we are able to have greater confidence in its predictions. And of course, you will have AI-driven observability as well. So AI will help us gain a more holistic, comprehensive understanding of our systems. AI can help us correlate data from various sources, identify hidden dependencies, and provide a deeper level insight into our system behavior. All right. So how can you get started? Step 1, focus on specific high-value use cases. So rather than trying to boil the ocean and fixing everything on day one, we should identify specific high-value use cases and leverage AI to make an impact with those use cases. Think about what the biggest pain points of our systems are. Where are we spending the most amount of money and effort? And we start with those areas. So for example, if the problem that you're facing is alert fatigue, then you focus on that first. Then building the right foundation. So any AI system is only as good as the data we use it, we train it on, right? So they need a solid foundation of data. This means that we need the right metrics. We have to store them properly. They should be available for analysis. And we have to invest in good monitoring tools and data pipelines. Clean, comprehensive, relevant data is essential. We also need to invest in skill development. So implementing AI isn't just for a tool at it, but we want to understand and bring our own skill in identifying what tool or what technique is applicable in a given situation. And this is also an ongoing thing. We train, we hire accordingly, and we keep ourselves updated. Right? So in essence, we start small, we create a roadmap, and we follow the roadmap. So to recap, we saw how AI, in particular how anomaly detection, can significantly transform SRE practices by leveraging we can achieve several benefits. We can reduce NPDR, we can identify and address our issues quickly, we can improve reliability, and we can increase our efficiency. So I encourage all of us to explore the possibilities that AI and anomaly detection in particular give to our SRE workflows. This may seem intimidating at first, but the potential for reward here is very high. And of course, we should start small, focus on specific use cases, have a roadmap, and then follow the roadmap. And then this is going to be an iterative process. So try something, and then we're going to improve it. Let's repeat. All right. Thank you so much for joining me today.